This clip is about descriptive statistics and, in detail, how to calculate the standard deviation. Produced by the Enphe, it's a part of a series of research knowledge clips based on the 5 steps of a research cycle. In this knowledge clip, the focus will be on step 3, research. The goal of the lecture is that you know how to calculate the standard deviation. In another clip, the point estimations and deviations are explained, except for the standard deviation. This is the formula of the standard deviation. Or for people who are afraid of maths, it's looking frightening, but it's not so difficult as it looks. First we will explain the symbols in the formula. After that we will give an example. The first symbol is the square root. Just use your calculator or you can find it yourself sometimes. Like the square root of 9 is 3 and of the number 16 it is 4. Then the symbol sigma. This means that the sum is taken, so all outcomes are added. Then the xy. These are the outcomes which are measured, so all the data the researchers collected. The y stands for the participant, so the outcome of the first participant is x1 and of the second participant is x2, and so on. Then the x with the roof. This is the average or mean. Here you can see that all outcomes are subtracted from this average. That is the square, multiplying by itself. And finally the n. This is the number of participants. Now we know all the symbols, but how does it work? In a graph it looks like this. When a researcher collected data, this could be the outcome. The blue dots are the measurements. The average of these measurements is 13. And you can see that there is a certain deviation of the results. The red graph expresses this deviation. To see how large the deviation is, all the outcomes can be subtracted from the average. Some outcomes are near to the average, while others are quite distant. And some are on the right side and some are on the left side. So some will have a negative and other a positive result. This is the start of the calculation of the standard deviation. The example here in numbers. So the first outcome found was 5. This outcome is subtracted from the average, which is 13. And this results in -8. This is also done for the other outcomes. Of course, there are more outcomes, and the higher outcomes will result in positive values. So when the highest outcome is 26, then the result will be 26 minus 3, so 13, positive. Underneath you can see the formula. The second step is to square these results. This will result in all positive numbers, because when the square of -8 is calculated, then this results in plus 64. This is done for all numbers. The step is also shown in the formula. Then the numbers are added. In the formula it's expressed as the sigma. The rather large result is called the total sum. Sometimes this is presented in an article. After that, the total sum is divided by the number of participants minus 1. And finally, the square root is taken. Then the calculation of the standard deviation is done. Of course, you can use a calculator, Excel, or statistical software to calculate it, but be aware of the steps which are used to calculate it. Now we have the standard deviation, but what does it mean? Because it's a mathematical calculation based on probability, the outcome has a certain standard. It is in the name already. This standard is that when one standard deviation is added to the average and one is subtracted, an interval is found. The center of that interval is the average. Because of the calculation, it is sure that 68% of the outcomes of the study are within this area. So we can describe 68% of the results using this area. When two standard deviations are added and two are subtracted, then a larger interval is found, double as large. Then 95% of the results of our experiment will be within this interval. This is useful to describe the deviation of a dataset. Finally, in literature, the standard deviation is often abbreviated by S or SD. And it is important to know that the standard deviation can only be used when the data set is normally distributed. So the most outcomes should be near the center and the other outcomes should be equally spread to both sides. When a normal distribution is found, then the standard deviation as well as an average can be calculated. In not normal distributed datasets, other point estimations and deviations must be used. Therefore, we have the median, modus, minimum, maximum, and percentiles. This was another step of the standard deviation.